Okay, so we are using version Q of the departmental review sheet for the final exam for MAT056. And what we're going to do right now is we're going to go over as many questions as we can in this time, all right? So basically the actual exam will have 20 questions, and they all short answers, and you must show your work to receive full credit, okay? And remember, it goes all the way from working with linear equations and formulas, then we transition into word problems, and then there are some equations in two variables, which are lines, talking about the slope, intercepts, then system of equations, then we covered the polynomials, different types of factoring, and then we have roots, different types of radicals, exponential expressions, logarithmic expression, and also some of the trigonometry. So this course had a lot of algebra, as as you're all aware, right? So let's go ahead and see what stuff we remember and what stuff do we need to review. I don't know if these questions in any particular order. It looks like they more or less go from the topics that we covered, but they're sometimes a little bit mixed, not in the order that the question appeared in the course. All right, so let's begin. So the first one is the algebraic expression, and it's asking you to simplify it, right? So take a moment and simplify it. Alrighty, so what do we do here to simplify that first? So you distribute, right? And notice that there are two sets of parentheses. So we begin with the one that are inner, and then you go into the outer. Okay, so we got 7x minus 5 bracket, and then, so let's distribute right away. So minus 12x, and then minus 6, minus 1. All right, now to make this a little easier, we can simplify that. All right. Negative 7. Distribute, and then what do you get? 35x, right? Plus 35. We combine like terms, and we get what? You good? Perfect. Okay. So that we're done. 42x plus 35 is the final answer. Okay. Next one is the formula. So we got solve for p, and we have a formula s equals to pr squared plus prs. And we're solving for the letter p. Right? So that's what we tried to do. Okay, so take a moment. All right, so what do you do? How do you get p by itself? Because the p appears, in two spots. Well, look, you see, if you're putting them on different sides, then you kind of putting them apart. And the goal is you want to keep p's together because that's what you're solving for, right? So you don't want to separate them. So you don't want to put them on the other side. You want them to be on the same side. Okay, what's the other option? Factor out the p. Factor out the p, because you see, by factoring out the p, you kind of isolating it. Now you don't have two of them, you only have one, because the goal is just to have it by itself. So yeah, you factor it out. And what were you going to have? R squared plus rs. You see, if the question asks us for a different letter, then it will be a different process. Here it's asking for p, so because p appears in both of the factors, we can take it out. All right, then by r squared plus rs, because now it's a factor, right? And whatever we do on one side, you're going to do it on the other. Okay, and then this goes away, and this is your final answer. S over S squared plus RS. Good? All right. Now, look, I mean, there's nothing going to be too exciting with the answer. Just going to be a bunch of variables because we don't know what the letters are. So we leave them in that form. as a formula. Okay, so again, we factor and we divide it. The goal is to isolate. Okay, in general, when you're solving for a variable, what you want to do is to first identify where the variable is, make sure it's on the same side, and if it's not, bring them on the same side, and then if you need, you factor it. If letter appears only once, then that's great. Then just have that term on itself, by itself. Everything else move on the other side, and then divide or multiply depending on what you are solving for. Okay, number 3 is not very pleasant looking equation, right? If you can see it. You can look at your review sheet. So it's 5, 6, x minus 3/4, 6x plus 5 plus 1 equals to 2/3, 9x minus 5, and then plus 5. Alright, so horrendous looking equation. So how do we solve these monsters? LCD would be the good way, right? You know, when we don't like them, when we don't like fractions, our goal is to get rid of them. And the best way to get rid of them is to find the least common denominator, and also, you know, some of you suggested maybe to try to get x by itself and, you know, move them all to, I mean, have all the terms containing x on one side. Listen, it's better to kill the fractions, otherwise this will become bad, right? Now look carefully. 5, 6x is by, you know, it's a fraction, that's fine. 3/4 is multiplied by 6x plus 5. So that 3/4 is belong to both, so we're not going to do anything to it. Now, but plus 1 is a separate term, a separate number right here. Since we're going to be finding the LCD, you will need to write that as a fraction as well. So we can write 1 as 1/1. And the same thing here, 2/3 belongs to both 9x minus 5, so we're not going to touch it. But 5 is by itself, so you're going to put that as well. And now you're going to be looking at the numbers that are in denominator, which is 6, 4, and 3. And here, that where we can find the LCD. So what would be the LCD of that? 12. 12 is smaller, right? Because we want a least common denominator. 24 will also work, but then you will have to deal with the larger numbers. So LCD will be 12. So let's go ahead and change everything into 12s. So 6 will be multiplying by what? 2. So going to be multiplied by 2. I'm just going to use different colors. So times 2 times 2. This one will be multiplying by 3/4 by 3. 1 we're going to be multiplying by 12. 2/3 we're going to be multiplying by 4. And 1 by 12, right? Okay, so let's see what we get. So 2 times 5 is, oh, now look. Now since we made all the denominators the same, instead of writing it over and over again under the same denominator, when the denominators are the same, to make the equation equal, the numerators have to be the same as well, right? So what you can do, you can freely take these denominators and just cross them out. Are you okay with that? All right, because the idea is to make the fraction equals, all these fractions equal. Denominators are already the same, so now we just have to deal with the numerators. So we're going to distribute. So we got 2 times 5 is 10x, right? Minus, well, let's just make our life here a little bit easier. I don't want to write it many times. 3 times 3 is, and this is minus 9, correct? So because it's a minus 9, we got to take minus 9 and distribute it. So let me highlight the minus so you don't lose it. You see that minus and not 9, this is what needs to be distributed. So if you distribute that, what do you get? Okay, and then okay, got it, right? You felt that it was wrong, right? Minus 45, all right? So careful, it's a common trap, that minus, you know, look out for it. All right, then plus what? 12, not 1, because remember the denominator, the common denominator was 12. So it's plus 12. Equals to, now what is that, Rod? 2 times 4? That's 8. All right, let's distribute it. 9 times 8? x minus, and then 5 times 12? 60, yep. 5 times 12. 50 plus 10, 60. All right, good. All right, now let's combine like terms. So on the left side, let's simplify both sides. So 10x take away 54x is negative 44x. Negative 45 plus 12. Good. And over here, 72x plus 20. Right? Negative 40 plus 60. All right, so now the equation became a little nicer, a lot nicer. How do we get x by itself next? Now we simplify both sides. Yeah, so now you have a choice. But basically, x's need to be together and numbers be together. I prefer to always move the one that is negative. This way, things stay positive. This is just my preference. So I have minus 44x, so I'm just going to do opposite to both sides. So I'm going to add it this way. All right, it's just, this way the x stays positive. This is useful, especially when you're solving inequalities. All right, so minus 33, 72 plus 42, 44. So it's 6 and 11. 116x plus 20. If you spot the error, let me know, okay? Don't want to get the wrong thing on this. It's good? What's next step? Well, look, if you move the 33 over, then you have x not by itself, right? 20 over. Whoops. Good. Minus 20. All right. 116x equals to negative 53. We're adding two negatives together. And then finally, by 160. Good? All right, so 53 and 116, no, right? If you multiply by 2 is 106, doesn't look like it's reducible. And we are so, used to numbers that are not nice in this class, right? So we don't say, oh, it must be wrong because the answer is not minus 2 or something, right? So that's okay. All right, question number 4, we have 3, what they call the absolute value equations. All right, so take a look at your review sheet. I'm just gonna writing it over here so it's bigger. Okay, so let me just open a new page, and I'll use row lines like that, and let's just go ahead and look at here. So question number 4. So the first one, A. So we have a linear absolute value in the equation. 4x minus 1 equals to 6. All right, so do you remember how these are solved? So tell me.
It's either that we plot x minus 1 equals negative 6 or same thing.
Equal to positive. Same. Okay, good. So it's either negative or positive. Remember, because the absolute value means the distance away from 0, so it's either positive or negative 6. All right, so now these are two relatively simple, right, linear equations, and we can just get x by itself. So let's move one over. So we got 4x equals to what?
7.
Careful.
What?
Oh, we're doing the negative first.
Okay. Negative 5.
Negative 5.
Okay, and then what is x? How do we solve for x?
Divided 4.
All right, and over here, 4x equals to 7, and x equals to 7 over 4. Right, 7 over 4. Okay, all right. So these are our two results. And then if you quickly check it, it looks like it's working. You're going to get negative 6, absolute value of negative 66 for both of them. Check out. Now I recommend you that you check all of these. Now B, 2x plus 5 absolute value equals to negative 2. Excellent. All right. Good. Why not?
An absolute value cannot give negative.
absolute value by the definition is the distance away from 0. Absolute value cannot be positive, cannot be negative, cannot be negative, and therefore there's no solution here. Absolutely correct. All right, good. Let's look at the other one. 5 take away absolute value of 3x plus 2 equals to negative 4. All right, so it's a negative again. So does that one have no solution as well?
No.
Well, we don't know because of that, other extra stuff there. So what are we gonna do?
Move over to 5.
Move over to 5. So trying to get the absolute value by itself, right? Okay. So let's move over to 5. So go away. Minus 5. Listen, that's negative still stays. You might be confused what that means, why there's a minus in there, but let's take care of this in a second. Let's just move 5 first. So negative 4 minus 5 is get rid of the negative, right? You want to get rid of that. The idea is it's the minus is done later. So just look at this and say, all right, in order for this to make sense, the absolute value of 3x plus 2 should be equal to what? 9. You see? And then if the minus is in front, then it becomes minus 9. You see it? Or you can think of this as an equation, so you divide both sides by a negative, or multiply both sides by a negative, and that gets you that. Now, you do not distribute the negative signs inside the absolute value. You don't do that. But because it's a minus, you can think of this like minus 1 in front, and then you're just dividing it both sides, so it becomes positive. And because it's a positive 9, we can work with it. We can solve it, right? So let's go ahead and solve this. The same way, right? So 3x plus 2 will be equal to what? 9. And 3x plus 2 will be equal to negative 9. All right, so now let's get x by itself. So minus 2 on both sides. So 3x equals to 7. And then divided by 3, 7/3. And this one, if you subtract, it gives us negative 11, and then divided by 3, it gives us negative 11/3. So 7/3 and negative 11/3 seems to be the answer. I just want to do a quick check. So when x equals to 7/3, then I substitute into the original. It's going to be 5 minus absolute value of 3 times 7/3 plus 2. Like that. Now notice that cancels. 7 plus 2 is 9. Correct? Absolute value of 9 is 9. 5 take away 9 is negative 4. I did a little bit quickly, but I just want to check to see if that's true. And the same thing with the minus 13 over 3, 11 over 3. I get 5 minus absolute value 3 times negative 11 over 3 plus 2. Let's see what that equals to. 3 cancels. Negative 11 plus 2 gives me negative 9. But the absolute value of negative 9 is still 9. 5 take away 9 is negative 4. Still checks. I understand we don't really like to check, given that we got the answer and we'll feel comfortable. But look, there's no rush. Got the answer. Might as well check it. So it checks. Good. We got the 2 solutions. All right, now question number 5 deals with the inequalities involving the absolute values. Okay, so let's write them down. And listen, it's also asking you to write the answer in the integral notation. Don't ignore that. If it says write in integral notation, we also want to make sure that you know how to do so. It's an important skill in pre-calculus and later to understand the integral notation. Okay, so let's just slow down, take a breath, and let you give you a moment to solve it. Okay. All right. So what do? So like in the absolute value equations, absolute value inequalities, you want to get the absolute value by itself. So yes, let's divide this by 2. Now careful, if it was negative, then dividing it or multiplying by a negative number flips the inequality symbol the other way. Okay, So here we got 2x. Here it's positive, so nothing will flip here. All right, now what does that mean? 2x plus 5 absolute value is greater or equal to 7? Somebody.
The number can be more than 7, but no less than 7. Wait, does that make sense?
First part did make sense. The other part is not correct, though. But it's good. I mean, you did it. This is definitely right. Remember, hundreds of other students potentially can listen to this, but no pressure, right? So greater or equal to 7. So that's one part, right? So if it's greater than 7, then it will work. You know that it's going to be correct. So that's correct, absolutely. But what's the other part? Well, equal to 7 is already included as there, right? So there's no, it's already part of that. But there's another side. Because remember, absolute value is a distance away from 0. Okay? So if you're 7 units or more away from 0, then you're good. You told me the positive side mode, right? 7 or more.
Right.
But also, because it's an absolute value, if you go to the other side of the number line, then you're going in the negative direction. So if you go 7 steps away and more, for example, -8, -9, -10, absolute value is still going to be bigger than 7. So basically, visually what it is, it's here's the 0, here's the 7, and here's the -7. It's like a radius, right? 7 to the right, 7 to the left. And then if you're saying greater or equal to 7, that means that you told me this side, right? Let me highlight it. This part. So it's this, greater than 7. But you can also go on the other side of the number line, which is going to the left of, you see it? Because this way, if you just pick a number, let's say -8, that's going to be greater than 7 under the absolute value. -9, -10, -11, all of that greater than 7. So basically, when you have a greater symbol, your inequality will go both ways, to the right of positive and to the left of negative. But not to the right and left of the same number, then otherwise you're going to have, everything is a solution, right? So that's what you do when it's greater, going to the other directions. Okay, so one of them you are right, so 2x plus 5 greater than 7, and the other one is going to be 2x plus 5 less or equal to -7. You got it. You see? So it's greater than a positive and less than a negative. That's when if it's greater. Okay? Some of you still look puzzled. When I review it, the idea is that it's an absolute value. And remember, when you take an absolute value of a number that's negative, big, it's going to be big, greater than whatever you want. So these are you split it into 2. And when you solve it, your answer will, what we say, diverge. It's going to go in different directions. So make sure that when you solve this, you look back and see whether that makes sense. So let's solve this. Let's move stuff around. Move 5 away. So 2x is greater than what? And then? So x is greater or equal to 1. And then the other way, let's move the 5 over. Subtract 5. So 2x less or equal to. All right, so now what do I do? Divide by 2. This is also a trap, kind of. If I divide by 2, does it mean I'm going to change the inequality symbol or no? No. Because a lot of people see that minus as there's a minus. Every time I say minus, I got to do something to it. It's not about whether it's a minus or plus. It's about whether you're dividing. The sign is important, but if you're dividing by a negative, that means it's going to flip. But if you're dividing by a positive, it stays the same. The other side is not important. So it's less than what? -6. Now let's do a picture, and then from the picture we can write the interval notation. So here's our diagram, a number line. Let's identify 1 and -6. Now the fact that there's also equal, greater or equal, less or equal, what do you do on a number line to show this? Shade it, right? The closed circle. So we got 1, and we got -6, right? So then you got greater than 1, and less than negative 6. You see it's going opposite directions? That tells you that, you know, it's a right diagram that you should get. Okay, and then once you got the diagram, then you should be able to write the interval notation. So go from left to right, so tell me.
Closed.
Negative infinity, Arsenio, good, then?
-6.
Negative 6.
One open and one closed.
This one open and this one?
Right. Yeah.
Okay, then?
Union.
Okay, then?
Right. One.
And?
Infinity.
Your pre-calculus class usually starts with this, okay? You need to be able to write the answer in interval notation and understand it. All right, good. So we solved this. Let's look at the other one. B. So it's 1 minus 2x less than 3. All right, so again, I'll give you a moment to see if you remember. Okay, so how does that work when it's less than? Kind of, but it's going to be opposite, right? So less than 3 visually, and it's a good idea to see this visually. Visually, here's a 0, here's 3 units. So it's 3 to the right, 3 to the left. Okay? So if you're less than, that means you are at most 3 units away from 0. So what is your interval that you're looking at? So is it going outside or is it going inside? Inside. So they're meeting. Okay, so they're converging between -3 and 3. So basically, I'll highlight it for you. It's this part. That's why you're in between. And in between, you squeeze in that equation. So 1 minus 2x will be right in between -3 and 3. Okay, so how do you write that? Well, you have a choice. You can either write it as 2 separate inequalities, like we did with the other one, which is greater than -3, and the other one less than -3. So you have a choice. Okay, do it whatever way you're comfortable with. You can do 1 minus 2x less than 3, and then you can do 1 minus 2x greater than -3. You see, it's opposite. Instead of saying greater and less, here it's less and greater. And then you can solve each. All right, let's do it that way, and then I'll show you how you write it as together. Right. So let's do it this way first. So if you write it this way, then let's do it. So go ahead, help me. How do you get x by itself for the first one? Move 1. All right. Minus 2x less than. I put the equal, no equal. Strictly less than. And 3 take away 1 is. Then by. All right. Good. You see how you already have good intuition for these things right away. -2, and you feel that it gotta change, and you're right, it has to. So it changes to a. Well, that's less now, so it becomes greater than what?
-1.
Yeah, let's be careful, right? We are dividing. 2 divided by -2 is -1. All right, let's do the other one. So -1 on each side, go away. -2x is greater than. Yeah, please be careful. You see, one of the thing that you can be, can get you, even if you know what you're doing, is the signs, right? And got to be very careful, because otherwise I can count the problem as right if you are made this mistake, especially combining. Anyway, so how do you get x by itself? By? Well, it's in front of x as -2, right? Okay, so you can divide it by -2 as well. Okay, so you got x and then less than and +2. All right, now, if you did it correctly, your diagram should be also coming together, meaning they're meeting. So if you do that, Here's minus 1, and there's no equality, there's no equal. So what does that mean if we plot it? Open circle. So we got minus 1 and positive 2. And look, it's greater, so it means it's going this way. And this one is less than, so it means it goes that way. And they meet, they converge, right? So what they share, in math we call it AND, or intersection. The intersection of two solutions is your result, okay? So, but look, the way you, yeah, you can write it that way. You should be able to write that using interval notation, and using interval notation is actually easier than the other one. So what will be the interval notation for this? Okay, then, right? That shows between -1 and 2. That's it, yeah. Now look, the way we also covered this in class, instead of writing this twice, it's actually easier when it comes to less than absolute value inequalities, is to write it as a compounded inequality. Compounded means you put them together in one. And that only works when you're doing the less than. And compounded simply says, look, I have 1 minus 2x squeezed in between negative and a positive 3. To write that using compounded inequalities like this. It's squeezed in between. So 1 minus 2x is in between. And look, it's greater than a negative and it's less than a positive. Do you remember these? It was been a while ago, right? But we have written it that way as well. It's compounded. And then you solve it simultaneously. Okay, by just getting x by itself. So look, if I want to get x by itself, what would I do? I got to move the 1, but now I don't have another side. I have all the 3 sides that I'm working on. So you're doing it by doing the doing the same thing on all sides. So you're going to subtract 1. So then it becomes -4 and 2, correct? And then to get rid of -2, divide by -2 each side. And because you are dividing by a negative, all of these inequalities are going to flip the sign. So that's going to be positive 2, that's greater, and that's going to be greater than -1. Looks weird because it's written the other way, but if you change the train, going the other way, going from right to left, if you read it from right to left, then it's going to be -1 less than x less than 2. You see? Which is the same thing as that. You remember, math, like a language, have sentence structure. But what's nice about math that is, languages don't have, is that math can be written both from left to right and from right to left. That's a very nice symmetrical relationship. And so if you have, if you know a language that you read it from the other side, right, from right to left, and for you, this would be even easier to see because you're just reading a sentence from right to left. So you got -1 less than x less than 2. Same idea. You see? So the result will be -1. But regardless, look, either you do it the other way, this way, or the other way, you're going to still get the answer that it's in between. Okay, we also call this conjunction together. All right, so these are inequality. Now we have another equation, and that equation is, well, that happened later in the semester, question number 6. Okay. Yeah, that happened when we were solving irrational equations. Equation involving rational expressions or fractions containing variables. Okay, so let me pause it and let me think of how would you do it. All right, so how do you do this? You need the common denominator basically, right? So to solve the rational equation, we find a common denominator. And just like that, once the denominators are the same, then we can make the numerators equal, and the equation will either result into the quadratic or linear. All right, so here the first one is okay, minus 1 over x minus 5 and 3 over x plus 5. So what's the LCD? Good. I'm going to use a different color to include, make the denominators the same. So first one is already what we want. The second one needs to be what? We need x plus 5. So look, I'm going to multiply that. One thing that you guys remember, it's always safe to put the parentheses, right? This way, you're not less likely to get the sign wrong. Because you're multiplying by x plus 5, not just by x followed by plus 5. X plus 5 is together. So that's why you want to put the parentheses there. And the same thing for the other one. So here we need what? You see? Include the parentheses, okay? The more you write, the better. Okay?
Where's 3 from?
3, I don't know. It's not there? So that's an imaginary 3 then. I have no idea. Look, losing my mind. All right, minus 5. In a different color now, well, whatever. So let's go ahead and now we have the same denominators, so we can just get rid of them, right? And then we just write the top, and I'm going to take my time and just going to rewrite this whole thing. The reason I did this is for you to see that negative 1 gets multiplied by x plus 5, not just x. And because of that, what will happen? It's going to be negative x and
Negative 5.
and you promised me you're not going to make that error, right? When you see a question like that and you need to distribute that negative, you're not going to forget that other sign? Promise me. Well, look, you got to get it right? Yeah, of course they happen, but you know they're easily avoidable if you remember, to include the parentheses, and they're common. And of course, you're not going to take 10 and minus 1 and make it a 9, right? These mistakes do not happen in our class, right? These do not happen. Okay, let's distribute to 3. We get what? All right. Let's simplify the left side. 10 take away 5 is 5. Okay, so this is a nice looking equation. So what do you want to do? Move the 15. I tend to, it's not a problem, but I tend to move the x first and then the number second. No different. Well, look, I'll move 15 just for you. There's no problem. So that's going to give us 20 minus x, and then so it gives us what? And then so x equals to, all right, the answer. Can we move on? Good. I know, say it with confidence. We have a rational expression. And one thing is with the rational expressions is that the denominator cannot be equal to 0. It can't. So we got to check to make sure that x equals to 5 right here does not make the denominators 0. And you already can see that it fails here and it also fails there. You see? 5 minus 5 is 0 and we cannot divide by 0. And 5 squared minus 25 is 0 and we cannot divide it by 0. And because of that, I know we work hard, we got the answer, but unfortunately, we got to say this is not a solution, and the answer is no solution. I know it's hard to let that go, that answer, because it looks fine and it works. It's not a solution because it cannot make the denominator equal to 0. Does that make sense? All right, so you check it. Sometimes you might have 2 answers. One of them might not work. Both of them might not work. Sometimes both work, so it's okay, right? Always check. Once again, look, the reason why there's no solution is because if you substitute that inside, you're going to have 5 squared minus 25 and then 10 divided by 0. And in pre-calculus, or ever again in any other class, if you see this 10 divided by 0 and someone asks what it equals to, you will never say 0. Okay? 10 divided, well, any number divided by 0 means that there's no result. There's no number that you multiply by 0 will give you 10. Okay, it's not possible, so this one is undefined. And in pre-calculus and calculus, you're going to learn that form, number divided by 0, has a lot of implications. It's a very important form in math. So that's why at this point, just remember, it's not 0. It's more than that. It's much more than that. But for now, it's undefined. There's no result, and because of that, there's no solution. Okay, Mo, does that make sense? Right? All right. Let's go on. Number 7. Another equation that is what is called the irrational equation. Number 7. So it is 5 over x squared plus 5 over 26 over x. Let me pause it again and see. Okay, so this equation is also a rational equation. So what do you do first? Least common denominator. And in this case, the least common denominator is just x squared. Now also write 5 over 1 so you can see it better, right? And now x squared is going to divide all of these denominators. So now we just need to make it the same. So what are we going to do with 5 over 1? Multiplied by x squared on top and on the bottom. And over here, it already has a one factor of x. So you don't need x squared in there. You only need one more factor of x. Now it all became x squared, so you can go ahead and cancel it out. And then let's write down what we got. 5 plus what? 5x squared equals to? And then you look at this, and it's important in this class to recognize, what equation are you dealing with. Okay? And good news, you either deal with the linear or quadratic. In this case, this equation is quadratic because of that square, you see? So then it's quadratic, and how do we solve quadratic equations? We either use quadratic formula or we use factoring, right? So you want to take all of this stuff, move it on the other side, make it equal to 0, and write that in the decreasing order of the exponents, right? So 5x squared minus 26x, and then plus 5 equal to 0. All right, and then it's your preference. I would recommend probably quadratic formula, but a lot of times, if you are comfortable with factoring, you can try to factor. So let's see, we're going to do both. So using factoring, okay, 5 is a prime number, so that's good. That means there's only one combination that will give you 5x squared, and that is 5x and x, right? So that's the only way. And another 5 is also prime. So in a problem like this, it's really not that many choices you can make to get the, what it is. It's either, it's 5, 1, 5, 1. So here, you can try first this, right? And here, it's a positive 5. So if it's a positive 5, they're either both positive or they're both negative. But because the middle term is negative, they both should be negative, right? Okay, you try this out and you get, what is it? This one is minus 5x, and the other one is also minus 5x. Minus 5x and minus 5x gives you negative 10x. So that tells you that the position of the numbers was not correct originally, right? So what you do is say, all right, that's not the right position, so you're going to switch the numbers, minus 5 and negative 1. So we're going to try to do it this way, 5x minus 1. And x minus 5. So that gives you negative 25, and that gives you negative 1, which gives you negative 26, and that's exactly what you want. All right, now remember, we didn't solve the equation yet, so 5x minus 1, x minus 5 equals to 0. And the reason we factor it, because now we can do what? What do you do next? Both equal to 0. Yep. So one answer is 5x equals to 1, so x equals to
1 over 5.
And the other one is positive 5. Look, in this class we talked about quadratic equation extensively, and when it comes to quadratic equation, these answers are rational. They're both different answers. So I'm expecting that if I use a quadratic formula, I'm probably going to have a nice number under the square root, the perfect square. So let's just, as practice, also solve this problem. So we're going back. 5x squared minus 26x plus 5 equals to 0. And let's do this using a quadratic formula. Oh, I forgot to mention, both of these numbers, a fifth and 1/5, do not make the denominator 0. You see? There's only one number that can make it 0, and that's 0. But 0 is not a solution. All right, so 1/5 and 5, both okay. You don't have to check the whole thing. These are the answers. Just making sure that the denominators are not 0. All right, so let's use a quadratic formula. Okay, so for the next week or so, right, make sure you know it by heart. So if someone wakes you up like in the middle of the night, it's like minus b plus or minus b squared minus 4ac divided by 2a, right? You got to know that formula. I mean, it is, you'll need it next semester as well. Okay, well, one thing that I've noticed when, checking your test is that for some reason you applying it incorrectly. Well, anyway, let's do it. So it's minus b plus or minus square root of b squared minus 4ac. And here's the mistake. It's the whole thing divided by 2a. So a lot of you taking that 2a and you're dividing it underneath the square root, and then you take the square root later. The whole thing is divided by 2a. That means you do it at the end. Okay? I would even recommend you that you do b squared minus 4ac separately. You discriminate separately, because this way, it will avoid having too many numbers over there. So I'll do it actually on the side. But let's write down what our a, b, and c are. A is 5, b is, and c is. All right, let's do b squared minus 4ac first. Right? So that would be what? 26 squared minus 4 times 5 times. Okay, so 26 squared by hand. Let me just write it over here. 12 for 5, so 676. Okay, so 676 minus, and this one is 100. $576. And what's the square root of 576? How much? 24. Well, that's kind of got to play around with this, because you see 26 is not, so it got to be a smaller number. Well, 25 is 625. You try 24, it happened to be, it's 576. So it is a perfect square, even though it is hard to recognize that it is. Okay, now what did I write? It's not a b. It's that's what the discriminant is, 576. And now let's put that in the equation, right? So it's x equals to minus b. So what would that be? Negative. Positive 26. Careful, because it's already minus. Putting the minus in front means it's the opposite sign. You see, so if it's a negative and then another negative, it will be positive. So it's 26 plus or minus square root of 576 divided by 2 times 5, right? Which is 10. Good. So now 26 plus or minus, you told me 24, right? Over 10. This is ugly 4. Here's better 4. Right? And then you have two solutions, right? So 26 plus 24 over 10. And 26 minus 24 over 10. So that gives you what? 50 over 10, which is 5. And this one is 2 over 10, which is 1 over 5. All right? So without a calculator, this is also, quite annoying, right? Doing this, but you do get the same answers. Alrighty, enough of this. Let's go on to the next question. Still quadratic equation. Number 8. I think you had a problem like that somewhere, I think on the exam, right? So number 8. Mm-hmm. All right, so you got two solutions. X equals to 5 over 2 and x equals to negative 5. And you asked to come up with the quadratic equation that has these roots. Remember, you had something similar. So, how do you do this?
We're going to get them back to the parentheses.
Back into the parentheses. I like that. What do you mean by that?
We're going to move the 5.
Or what do you want to start with?
We're going to move the -5 inside.
All right, so if you're working with x minus 5 and you move, what does it become?
X plus 5 equals 0.
So if x equals to -5, then we know that x plus 5 equals to 0. And then the other one is x.
You know, 2x.
Yeah. So can we get rid of the, let's get rid of a fraction. Let's cross multiply. So just, it's better to deal with the factors that don't have fractions. So it's going to be what? 2x equals to 5. And then let's move it.
Yeah.
So it becomes what? 2x
Minus 1.
equals to
0.
You see what we did? It's just better to deal with the whole numbers than fractions. So you cross multiply, you got 2x equals to 5, and then you moved it over, equals to that. All right, so now how are you going to put them together?
Distribute.
Yeah, but what do you do? Multiplying, right? So basically, you see, we're doing the property of 0, but we're doing it in reverse. You see, we're doing the steps in reverse. Like, imagine if I were to, right now, what you can do is, we can solve this problem, and then you can, if you had an option to play the video the other way, then if you play the video the other way, it's going to be solving an equation. You see what you're doing? So basically, if you go forward, you are chasing it back. So it's like playing the tape. I don't know, can you two play the other way? All right, for those of you who are watching it, figure it out, right? See if you can reverse it. All right, anyway, so let's go ahead and distribute it. So if you distribute it, well, definitely the speech-wise is going to be weird, right, when you talk. But the video will be going fine. All right. Anyway, let's distribute. So, but you got the idea, right? If these are the roots, then if you care about the terminology, that these are called factors, right? And then you're distributing them out, and you get your polynomial that gives you those factors. All right. So let's multiply this out. So 2x squared plus 10x
Minus 1x.
and then
Minus 1y.
so it's 2x squared plus 5x minus 25 equals to 0, and the question is asking us to come up with the equation, right? Write down a quadratic equation that has that roots. All right, so here we go, we got it. So that equation has those roots. This is one of the concepts that's pretty important in pre-calculus. All right, you're going to revisit it and you'll see it again. So make sure that you understand it. And if you are, you're in a good shape already. All right, number 9. Okay, I can scroll up if you didn't finish. Okay, so number 9 is all right. So now we're jumping to earlier topics, and that is finding the intercepts and all this, about the stuff about lines. And most of this is the same thing as elementary algebra. There's nothing new. All right, we spent maybe one class on this, so you might have a question also on the final covering this. So let's see if you remember. So if this is the equation, now notice there are two variables. Both of them don't have any exponents on top. Okay, so this is a linear equation in two variables. All right, so we know it's going to be a line. Graph of this is a line. And this question in particular asking you to just find the intercepts, right? Mm-hmm. And graph, right? So the intercepts basically should be straightforward, right? So you got the x and you got the y. So first is the y-intercept. You make x equal to 0. And then the x-intercept, make y equal to 0, right? So when x equals to 0, so you set x equal to 0. Then you get 0 minus 4y equals to 20. So y is negative
5.
And then we're going to make y equal to 0. So you're going to get 5x equals to 20. So x equals to 4. These are like the best type of problems, right? So it's boom, 0, 0, find the 2 points, and then you quickly plot them. So you got 0 minus 5. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4. And then we nicely connect them. And extend it. Don't stop just at those points. I tend to, don't understand this, but I see it all the time that you put that point and people just connect it and they don't go beyond it. You want to extend it because the idea is that linear equation and two variables have infinitely many solutions. That's why this line never ends. That's why I gotta extend it. It's not just between those 2 points. It's everywhere. I have the constant slope. All right, number 10 and 11, also about the lines. So question number 10. All right, so you got an equation 2x plus 3y equals to 6. And you want to find the equation that will go through the point 1, 1, and it will be perpendicular to this line. All right, I just abbreviated this way. Okay, let me pause it and see if you can resume it. All right, so this equation that we're looking for needs to go through the point 1, 1 and perpendicular to that line. All right, so let me repeat myself. So when it comes to finding equation of a line, any line, all right, you have 2 forms of the line that you should know. Okay, both are equally important. One is y equals to mx plus b, okay, which is the point, it's a slope intercept. And the other one is the, what is called point, and the other one is called point slope. And point slope equation is like this. Y take away y1 equals to m multiplied by x minus x1. And just something to note that you see that y and x right here, these are variables and you don't touch them. They stay the way they are. The things that basically you need is the other stuff that I did not highlight. You need to know the slope and you need to know the point. All right, how do you find it? Well, basically what is given to us is that the line is perpendicular. Perpendicular means that the slope is equal to slope of a perpendicular line is the negative reciprocal of the original. I'm going to write it that way. So basically you flip the fraction and you change the sign. Flip and change. All right, but how can we find what's the negative reciprocal of something that we don't know the slope of? So basically the first step is to find the slope of the line that's given. And that can be a question by itself. How are you going to find the slope of a line like this if it's given in that form? Yes, you put it in mx plus b form because that's where the slope will be right in front of the x. So we're going to take the 2x and we will move it over. And then we're going to divide it by 3, right? And then we're going to get that, negative 2/3 x. And the other thing is not important. The fact that it's plus 2, that doesn't really matter. What we care about is this number in front of x. Okay, so that's the slope. You see it? Okay, so that's the slope of the line. So this line that has a negative, the line that is perpendicular to it has to have a slope that is flip and change, right? So if you flip it, it becomes what?
3 over 2.
Oh, how did that happen? I didn't think of that question. Weird. Okay, anyway, so it's 3 over 2 and you change the sign. So 3 over 2. Okay? Alright, so are we done? And then you ask, what was the question, right? Like, what's going on right here? So the question is, write the equation of the line, right? So what is the equation through point 1, 1? So basically now we got to put this together. So we got the slope, m, the one that we found of that line, is 3 over 2. We got the point, 1, 1. And from these two pieces, we can come up with the equation. How? So either point slope or find the intercept, either way. It tends to be that students more comfortable with using mx plus b, but they're going to do both. And the reason is that, again, for the pre-calculus and calculus, that other form is also important. So I'll do both. Let's do it first, the one that you suggested, and that using mx plus b. So tell me what to do.
1
1 where? Until the y?
Y
Y, okay, then
equal 3 over 2. Wait, am I going to write the 1?
where? That's 1, right? mx, so times 1 and then plus
Plus
b, right?
b.
Oops. And that's what we're looking for. Right? So we substituted the x, the y, the m, and now we need to get b. So a little bit of arithmetic right here. So it's 3/2 plus b. And then, how do you get b by itself? Yeah, you see here you got to deal with this fraction right here. Not very pleasant, but what you got to do? What are you going to do? That's actually, you know, when I'll show you to do it the other way, it's actually easier. So what is it? 1 take away 3/2. We don't like to do these things, right? 1 minus 3/2. Well, write it over 1, multiply it by 2, and it's 2 take away 3. And 2 take away 3 is -1. This is like the worst intercept I've seen, right? -1/2. Well, so what's the answer? So we got all these things going on. So where's the final answer? I gotta write the equation. Y equals to
3 over 2x minus 1.
bless you. Right? The other thing you see, the thing that I highlighted earlier, you do not put the numbers in there in your final answer because it's an equation, right? So basically what we did, let me just zoom out a little bit so you can see the whole thing, right? And let me go back and also look at that question, and I'm telling you, it is easier to do it this way, like that. All right? And this right here, y1, x1, that represents the point. All right? So the point that you got is 1, 1. So this is your point, x1, y1. So you can just substitute. So it's y minus 1 equals to the slope, which is what? And then x minus. And the question wasn't specific. It says write the equation. So that's the answer already. It is the answer already, and you don't have to do anything more. Now you might say, but no, it always have to be written on mx plus b. Not really, unless they ask you to, right? But if you feel that, you know, you want to see that this is the same thing, you can distribute, add 1 to the both sides, and you're going to get 3/2 x, and then minus 3/2 plus 1 is minus 1/2. Because 3/2 is 1 1/2 plus 1, that's -1/2. But there's nothing wrong with leaving this in either form. Now, you might not like that question much just because of the number that b, the intercept, was a fraction. But the process itself, that's what's important, the process. And the process is find the slope. Here was negative reciprocal. And then write the equation using the information that's given. Okay? Question number 11 is very similar. So see if you can do it yourself. All right, so what problem is that? Number 11. Okay, guys, so number 11, you got the point 4, -1, and you have an equation that's parallel to 5x minus 4y equals to -5. All right, so tell me what to do first. Find the slope, right? It's parallel. So we got to find the slope of that line. So as before, let's take the 5x, let's move it over. It's minus 5x, take away 5. And then to get y by itself, by -4. Okay, -4, careful with the signs. Each thing gets divided by a -4. So it cancels out. So you get y equals to 5 over 4x plus 5 over 4. Does this look good? Okay, what's the slope? Where's the slope? Here it is. That's the slope. And this slope is same for that other line. All right, so that means this line, the one that we're looking for, will be parallel. So we're going to have the same slope, 5 over 4. And now using this information, we're going to write the equation. So what do you like to do? mx plus b or the other one? No, well, I mean, it doesn't matter. You're asking, I heard the question. The reason I don't like the other one, I mean, this one, mx plus b, I'm a little bit biased towards, how it's presented in calculus, and in calculus, when it comes to the equation of a line, which is a very big part of the course, which is a tangent line that you discuss, there, you will be asked to write a lot of those equations, and it's much quicker to get the answer for the other one. You don't have to solve for b, because there's nothing special about the b. The other one just gives you a general equation using any point on the slope, and it's immediate. You don't have to solve for anything. That's why the other one is preferred. As you go further in math, you will see that. But it doesn't matter. Look, we can still use that. And I know students in calculus, even to that level, they still like mx plus b, and they still use it. So it's not a big deal, right? So yeah, let's keep it, whatever. 5 4 over x, 5 over 4x plus b, right? And now we got to solve for b, so we're going to substitute, so x is 4 and y is -1. So x is 4 plus b, and then boom, boom, correct? And you're left with -1 equals to 5 plus b, and then minus 5 from both sides, and that gives you, okay. Oh yeah, and the other form, you're not asked to solve any equations. That's also a good thing. There's no need to solve for anything. You just plug it in. All right, so where's the answer? Just put that back, right? So y equals to 5 over 4x, take away 6. Final result. Okay? All right. Let me leave it a piece right here. All right. Where are we at? Number 12. Okay, so we have another line written in a weird way. Oops. X over 2 plus y over 8. This is called the general form of a line because both x and y are on the same side. And you ask to find a slope of that line, right? So that's where that other form is actually useful, right? And that's mx plus b, because when you put it in that form, the slope will be right in front. So tell me what to do. What's the goal? What do you mean? Like x times 8 and y times 2?
Yeah.
Careful, because if you do this, then you are, it's not a proportion, so you don't have a left side and a right side. You can only cross multiply when you have one fraction on the left side and one fraction on the right. Here we have 3 things. You see it? So you can cross multiply all 3, and again, the stuff on the left side, is not an equation. So you can find a common denominator if you want to combine. That's a different story. But again, I don't know if you want to do that here either. Common denominator?
Yeah.
Sure, and I'll follow what you told me, and then I'll tell you maybe the way I look at it. Okay. So what's the LCD?
8.
Okay, then what?
That's 2 times 4, x times 4.
Oh yeah, that's good. I like it. So that one is going to be 2 times 4, 2 times 4, and this one is nothing, right? 1 and 8. I see what you're doing. You just want to get rid of all the fractions, right? Okay, I hear
It's
you.
going to be 4x plus y equal 8.
All right, and then
Move the 4x to the other side. It's going to be negative 4x plus 8. The slope is going to be negative 4.
yeah, I see it. I like it. Yeah, so common denominator, and then get rid of it, and then combine it like that. Yeah, perfect. That's good. Yeah, and what I was thinking is first to move x over 2 on the other side, but then again, you would still have to get rid of the fraction. So yeah, see, fractions, get rid of that. Yeah, I like that. Number 13 and 14, these 2 quick questions on doing arithmetic with the complex numbers. The only thing you basically need to remember about complex numbers and what is this imaginary part, imaginary number I, and imaginary number I is defined as what? Not -1, but
Negative root negative 1.
The root of -1.
Yes.
It's a number such that when you square that number, it is -1. When you square it. Okay? So that's proper. And basically, the most common way we see it is when we square that, it equals to -1. Keep that in mind when you're doing arithmetic with them. All right, so number 13 is subtracting the two complex numbers. So 3 minus 4i, take away 2 minus I, and you deal it the same way as if it was an algebraic expression. So you simplify it, so tell me what you get. Minus and good, plus say with confidence it's a negative times a negative, that's a positive, right? You remember you promised, well, kind of, some of you promised me you're not going to make that error, right? The negative and the negative become a positive. All right, let's combine this and put it in the form where the real part comes first, the imaginary part comes second. So 3 take away 2 is what?
1.
And -4i plus I is? Okay? Any questions? All right. Number 14, multiplying them. 4 plus 2i multiplied by... Right. Let's go ahead. What do we do? What are we doing? Distributing it. Boom, 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 boom. Right? So 4 times 5 is 20, then minus what? 12i, then?
Plus 12i.
Okay, and then?
Minus 6i squared.
Good. And let's not jump ahead. You know, we're going to simplify in the next step. All right, so 20 is 20. Negative 12 plus 10?
Negative 2.
Negative 2.
I. And then negative 6i squared becomes?
Plus 6.
Plus 6. So I squared is -1 right here, right? And then negative 6 times -1 is positive 6. Combine again the numbers here. 20 plus 6 is minus. Final answer. Okay, so that was fun. Now we got to look at something that looks not very pleasant. Number 15. And these are complex fractions. But I remember you used to like it. I don't know if you still like them. Alrighty, so what can you tell me? How are you gonna do this? Let me give you a few minutes to think about this. All right. So how do you do A? How do you begin? Oh, you want to do it like write them all as fractions? Okay. Hold on. What's going on? All right, good. So AB over 1, like this. All right, and why would you do that? That's good. Give them all the same denominator? Okay, so I'm going to follow your suggestion, and then we'll look at the others as well. And you tell me what makes sense to you. So what's LCD? All right, so now you're going to give them all AB, right? Okay, so this one doesn't have anything, so you're going to multiply by AB. So here and here. All right, so this one right here, you need what? For the first one, A, and this one needs, all right. Okay, so let's write this out. So the top is AB times AB is what? Do you want to cancel denominators now, or are you going to do it later? What do you want to do? Or you want to keep them? Cancel them, right. So now you have all these ABs, so you can actually go ahead and cancel the denominators because now they're the same. And what's left? AB times AB. What's AB times AB? And the bottom is? Okay. Is that the final answer? Yes. Remember, the good old rule is don't get yourself in trouble, right? When it comes to these simplifying, don't invent the new techniques. There are no same factors, so you can't cancel them out. So it's the final answer. Well, if you create something new, that would be great. But yeah, algebra is difficult to reinvent, right? Very. So good. All right. Anyone did it the other way? By something else, like instead of finding the LCDs and writing it this way and canceling out, perhaps we've done something different. Yeah? Otal? So tell me what you did. So you got the LCD, which is AB, right? That's the same. And then you kept it, I guess, this way, right? And then did you combine the fractions on the bottom?
Yeah, on the bottom.
Right. So it would be basically the same idea, right? So it's going to be A over AB plus another B over AB, right? And then you have the common denominator. And then you added it, right?
Yeah.
All right. And then you got this staircase. A plus B over AB. And then what did you do with that?
AB.
Yeah.
And
Right. Okay. So it's AB over AB, B over AB.
equal to AB over A plus B.
Okay, so you flipped the fraction.
Yeah.
Yeah, you did some acrobatics with the fractions, right? You're dividing by a fraction is the same thing as multiplying by the reciprocal. So you flip this over. And then basically you ended up with the same result, right? A squared B squared over A plus B. Right? And you can simplify it because the denominator is not a multiplication, it's a sum. So there's no formulas here that we can use. So that's a final result. Okay? There's yet another way to do this, and that is multiply everything by LCD. Okay? So the third way to do it, so that's the first way, that's the second way, that's the third way. So the third way is to take the, this is the original question, right? And again, what's the LCD? Multiply everything by AB, the top and the bottom. So you multiply this one by AB, you multiply this one by AB, and you multiply that one by AB. As long as you multiply everything by the LCD, then it will stay the same. The fraction will stay equal. So then here AB times AB is A squared B squared, and then the bottom is, you see B and B cancels, so you let A, and then A and A cancel, you're left with the B. Same answer. Alright, that's a little bit neater. Right? You don't have to flip things around, and over there it's not as too many things, one fraction, the other fraction. But either way is okay. I believe that it's preferred that the question of these, of double fraction, are actually done this third way, by multiplying by common denominator. It just makes it cleaner. Alright, but you choice. So for example, part B, right, of that same question, part B is 1 over x squared plus 1 over y squared, and then y over x and x over y. You see here, here are 4 fractions. You can find the LCD for all 4 and go ahead and either rewrite them with the same denominator or multiply by the same denominator. So what's the LCD here?
X squared by
And now let's go ahead, I'm going to use a different color, and let me just put that for each of them. So x squared, y squared over 1. I'm writing it over 1 so you can see it better. Same thing here. Something here. Right? And then the favorite thing that we do in math, in algebra, and that is start reducing stuff, right? So in the first one, we're going to reduce every denominator because we're multiplying by LCD, all the denominators will go away. So x squared goes away, y squared goes away, x goes away, 1x remain, y goes away, 1y remain. A little messy, but I hope you can see it. So what will be the top? Plus x squared, right? And the bottom is,
X, Y squared.
yeah, x, y
Cube.
cubed.
Y
Yeah, because it's y squared times y. And here it is,
X cubed Y.
all right. And just to make it look nicer, we usually factor. It should make, well, not just to make it look nicer, we also want to make sure that it doesn't have common things that we can cancel. So let's check it out. Does the denominator have GCF? Oh yes. What is it?
X is
And then we take this out. What do we get?
Y squared plus X squared.
All right. Well, look at this. If we didn't do this, we would have gotten it wrong, because then we wouldn't recognize that we have the same thing on top and the bottom. You see it? And they are completely the same. When they're completely the same, you can go ahead and reduce. And then you went that far, so don't screw up your final answer. It's still a fraction, right? So the answer will be 1 over xy. Another mistake that sometimes I feel sad about, like you did the math and at the end it's like things cancel. It's like, all right, 3. Don't, right? 2 6 is 1/3. You know, if it simplifies, keep it in a fraction form, right? And that's what we got right here. So you see, I mean, it's a nice problem, has a lot of pieces, but you know, it's that's what you got. All right, let's do C, and then we do 16, and then we'll finish this part. Okay. All right. So part C, we got 1 plus 1 over x minus 2, and 1 minus 3 over x plus 2. LCD. Alright, so I'm going to use the same method if you don't mind, right? Just rewriting it as a fraction over here and multiplying it by LCD. Okay? And just a lot of writing now. Okay, so let's do this. Multiplying by LCD. So x minus 2, x plus 2, x minus 2, x plus 2, x minus 2 plus 2, and x minus 2 plus 2. Okay. Now let's start canceling, right? So x minus 2 goes away, x minus 2 goes away, x plus 2 goes away, x plus 2 goes away. And now you got to do a lot of multiplying and simplifying. But x minus 2 times x plus 2 is what? Difference of the squares coming out of that class, definitely, recognize that. So that's x squared minus 4. And here's going to be plus x plus 2. And notice it's a plus, so the sign will not change. The bottom is also x squared minus 4. But now, once again, look. And all of those tricky ones where there's a minus 3 times something. So what would you do? If you want to distribute, what do you get? And then plus 6. You see? It's a plus that, again, the minus sign that will distribute it. So you got x squared plus x minus 2. I'm putting that in a quadratic form. Quadratic expression. In order. And then the denominator is x squared minus 3x and plus 2. So what do you think? The final answer? No, you see these quadratics. So now let's have fun factoring this. Boom, boom. Are we hoping that they're factorable? They probably are. But they might not, right? But let's see. Negative 2 is a nice number, so there's only 2 factors of that. 2 and 1, right? So tell me which one plus, which one minus. All right, and over here, x, and then either both minus or both plus, because this one is positive, right? So it will be. All right, and they conveniently located. Right? Which you can cancel. And And that will be the final answer. Right? Oh, I should have asked. Too late, right? But is this a final answer? Yeah. I mean, you're not gonna be just simplifying it more. All right. Okay, we're almost done with this part. So question 16. So part A is 15x squared plus 11x minus 6 equal to 0, and it's asking you to solve for x and you express your answer in simplified radical form if possible. Okay? So let me pause it, give you time to do it. Do the part A. Okay, guys, so were you able to factor this? Did anyone try? Yeah, it's not factorable. If you try, you'll see that it's not going to work. So we kind of have no choice but to use the quadratic formula. So let's write it again. And once again, remember this whole thing is divided by 2a, so you do it later. And again, I recommend that we do b squared minus 4ac first. Right? So a is this, b is that, c is negative 6. So let's plug it in. So b squared will be what? So it's 11 squared minus 4 times 15 times negative 6. When you substitute, make sure you use the parentheses, don't lose any signs. I keep seeing people, kind of messing up with the signs, forgetting one, and then this whole thing will go wrong if you are not substituting things correctly, right? So it's 11 squared minus 4 times a, 15, c, negative 6. So you're right, 121. And then here is 4 times 15 times 6 and 2 negatives. So it will become positive. And how much? 360. Yeah. 4 times 15 is 60. And 60 times 6 is 360.
No, I was right and he said he got a 384, so I was like, no, how did he get?
Yeah, that's so here is 360, right? Because it's 60 times 6. And don't do other common error what people do, which is an error that should be avoided, and that people distribute. They do 4 times 15 and then 4 times 6 and then multiply those numbers. This is not sum, it's just multiplying 3 numbers together. All right, so it's one multiplication, 4 times 15 times 6, and then 2 negatives gives you a positive. All right, so that's 4. Okay, so that's together once you combine. All right, fine. So now let's go ahead and put that into the formula. So minus b is negative 11 plus or minus square root of divided by, and 481 is not cannot be reduced further. Okay, if you add the digits, 4 plus 8 plus 1 is 13. So if you use like divisibility rules, it's not divisible by any numbers that, like, it's not divisible by 3, it's not divisible by 9. So, I mean, what else is divisible by? 5? No. 10? No. So you can quickly go through it. It's not really a nice number, 481. And definitely not a perfect square. So good. Less work to do. That's the answer. That's it. Yeah, negative 11 plus and minus square root of 481 divided by 30. Let's do B. Okay, B, where are you? Oh, my eyes are jumped. Okay, x squared plus 2x minus 5 equals to 0. Looks like a nice, innocent looking equation. But then if you try to factor it, don't force it to be factorable, right? Just don't. So 5 times 1, there's no way you can get 2 out of it, right? So leave it alone and use the quadratic formula right away, right? So x equals to, I don't have to rewrite it again, right? So let's do the discriminant. Well, why am I writing x? I want to do discriminant for another reason. Remember, we studied what the discriminant means. So let's just compute it. B squared minus 4ac. So b is what? 2 squared minus 4 times what?
1.
And negative 5 again, right? So it's going to be 4. Negative and negative is positive 20. What does 24 tells you if it's a discriminant? What does it tell you? What kind of solution you get? Is it real or imaginary?
Real.
Real. Because it's positive. And is it rational or irrational? Why? It's not a perfect square. If it was a 25, then it would be rational. It's irrational, so because it's not a perfect square, so that means our answer will have some ugly-looking square roots, right? Right. So x equals to minus b plus or minus square root of what we got. Yeah, I don't have to write minus b. We can put it right away. What is it? Minus 2 plus or minus square root of over times 1, so it's 2. And in a problem like that, 24 has a lot of different factors, so you should simplify that. So it's minus 2 plus or minus what? 3 and 8, not good. 3 and 4 is 12. 4 and 6, good. 4 and 6. The whole thing is divided by 2. I keep saying it, right? Not 4 divided by 2, the whole thing. So you're dividing it by 2 all the way at the end, not now. So it's minus 2 plus or minus 2 square root of 6, because square root of 4 is 2, so you can take it out. And then at this point, you see, when you have the whole thing divided by 2, I suggest that you get used to just writing it this way, like with complex numbers. You divide one by 2, and you divide the other one by 2, like this. And if one of them is not divisible by 2 or whatever other number is, then leave it alone. You can also factor if you like, but I mean, this is the way you can break this down. And then what is negative 2 divided by 2? Plus or minus square root of 6. Okay, so that's the final answer right there. Okay, so